We're finding zeros of polynomial functions. First, we'll do a little bit of a review. We're going to find zeros of some different polynomial functions. Let's take example A. So we want to find zeros. What that means, we set f of x equal to 0. So 0 equals x minus 4. We solve that, and we say that the 0 at x equals 4. Okay, next one. B. Set it equal to 0, and we're going to factor the x squared minus 4x plus 4. So 0 equals, this is a x minus 2 times x minus 2. And so the zeros at x equals 2 and x equals 2, so there's two of them. But here we would say it has a multiplicity of 2. So because it's an x squared term, we know there's going to, typically we say there's up to 2 zeros, but that's when we were talking real numbers. Now that we are using real and imaginary numbers, we can say there are exactly 2 zeros for x equals 2. So that means the next one, C, it's x cubed, means there are exactly 3 zeros. So first we're going to factor an x out. So we're saying 0 equals x times x squared plus 9. That means x equals 0 is one of our zeros. And we can factor the x squared plus 9 into x plus 3i and x minus 3i. And so that means our zeros, we have the x equals 0, that's a 0, and x equals plus 3i and x equals minus 3i. There's our 3 zeros. So we'd say zeros at x equals 0 and plus or minus 3i. All right, let's look at D. We know we're going to have 4 zeros. So what we want to start off with is factoring this. Set it equals 0. So 0 is equal to factors of x to the 4th minus 1. Be x squared minus 1 and x squared plus 1. Now we can factor each one of these again. The x squared plus 1 is a x minus 1 and a x plus 1. And the x squared, so that's this, the x squared plus 1 is going to factor into x plus I and x minus I. So our 4 zeros are going to be at x equals plus or minus 1 and x equals plus or minus I. Okay, now we're going to look at the rational zero test. The example is find the rational zeros of f of x equals x cubed minus 5x squared plus 2x plus 8. The rational zero test tells us that this last value without an x, we're going to call that p. The coefficient of your highest term, in this case x cubed, is a 1, and we're going to call that value q. Then we're going to set up a ratio of p over q equals, and it's going to be plus or minus, then we draw a line, and in the numerator we list all of the factors of p, which is 8. So all the factors of 8 are 1, 2, 4, and 8. In the denominator, q, we list all of the factors of the coefficient of x cubed, so that's just 1. And so this tells us that our zeros could include either x plus or minus 1, plus or minus 2, plus or minus 3, plus or minus, oh, not 3, plus or minus 1, 2, 4, and 8. So at this point, we're going to set up a division. It's going to be a synthetic division. And it usually tends to be a trial and error. So we take our equation and we write the coefficients. 1 minus 5, 2, and 8. And now we're just going to guess at what a factor of this is going to be. So I'm going to say, let's just say x plus 1 is a factor, and we're going to test it out. So we put a 1 right here, and we do synthetic division. Bring our 1 down. So 1 times 1 is 1. Minus 5 and 1 is a minus 4. 1 times minus 4 is minus 4. 2 and minus 4 is a minus 2. 1 times minus 2, and 6. And because we don't have a 0 here, we have a 6. That means that x plus 1 is not a factor. And so we can cross this off. Has to be a 0 right here for it to be a factor. So let's try it again. This time let's try a negative 1. So we're going to put a negative 1 here. Draw our line. 1 minus 5, 2, and 8. Bring our 1 down. So negative 1 times 1 is negative 1. Negative 1 and negative 5 is negative 6. Negative 1 times negative 6, 6. 2 and 6 is 8. Negative 1 times 8, negative 8. And we have 0. So this means that x minus 1 is one of the factors. And what we have left from the bottom here, this is, since we started out at x cubed, this is going to be x squared minus 6x plus 8. And this we can factor as x minus 4 and an x minus 2. So x minus 4 times x minus 2. And so the three factors, and we set it equal to 0. It's going to be 0 equals, our first factor is x minus 1, then x minus 4, and x minus 2. Those are the factors, so we can say our zeros at x equals 1, 2, and 4. And that is our answer. Zeros 1, 2, 4. Okay, the next example, we're going to find rational zeros of f of x equals 2x to the 4th minus 9x cubed minus 18x squared plus 71x minus 30. So this is a rather long problem. And so first thing we're going to do is do our P over Q, find all possible rational or fractions that could be factors of P over Q, which is going to be 30 over 2. So, and they're going to be plus and minus, then draw a line. So we're going to look at factors of 30. So we have 1, 2, 3, 5, 6, 10, 15, and 30. And then factors of 2 is just 1 and 2. So all the potential combinations we're looking at, we divide everything by the first one in the denominator. And then we look at all these numbers in P divided by the other number in the denominator, and we don't want to repeat anything. So we would have a 1/2 plus or minus. These are all plus or minus. 1/2, because that's this one divided by that 2. And we have a 2 over 2, but we already have that as 1. 3 over 2 is not included yet. 5 over 2. Then 6 over 2, well, that's 3. That's already included. 10 over 2 is 5. That's already included. 15 over 2. And then 30 over 2, which is 15, already included. So All of these are plus and minus. Let me put these in red, circle in red. These are potential zeros, and they are plus and minus. So next thing we're going to do is set up our synthetic division. So we use all of our coefficients, and that's going to be, well, let me draw the, okay, our numbers are going to be 2, -9, -18, 71, -30. Those are the factors in the equation f of x equals, so on, 2x to the fourth minus 9x cubed minus 18x squared plus 71x minus 30. And we're going to try 2, which means, put 2 here. So this means we're seeing as x minus 2 is a factor. I already know it is because I looked at the graph, and you can tell from a graph, notice that this is a 2x to the fourth is a positive even, so it's going to go up on the left and up on the right, and it's going to have a couple more zeros because it's x to the fourth. And we'll see if they're all real zeros or not. So I happen to know that 2 is a 0, so let's just go ahead and do our synthetic division. We'll bring down the 2. 2 times 2 is 4. 4 and -9 is -5. 2 times -5, -10. And this would be -28. 2 times -28 is -56. Add those two is 15. 2 times 15 is 30. And then this would be 0. So this means our factor x minus 2 is a factor. And then this is times. So we drop down 1 power of x. So this is going to be 2x cubed minus 5x squared minus 28x plus 15. So if we don't see a factor in that, then we can just go ahead and do synthetic division again. So we'll just, which is what we're going to do. So we'll bring down those numbers. So we have a 2, -5, -28, and 15. And this time I'm going to use a -3, which means x plus 3 would be a factor. And I happen to know that, again, from looking at the graph. If you don't graph it first, you're just going to be a trial and error on these. So we just bring the 2 down. -3 times 2, -6. -11. This is going to be 33. 33 -28 is 5. -3 times 5, -15. And then this is 0. So this is 2x squared minus 11x plus 5. And our factors times that, we have a x plus 3, and the first one, x minus 2. So we look at this and see if we can factor that, and it turns out we can. If we couldn't real easy, we'd just do another synthetic division, but this factors out to be a 2x and x, and then this is going to be a -1 and a -5. So we can say 0 equals, and all of our factors are x minus 2, x plus 3, 2x minus 1, x minus 5. And so the zeros at x equals, we have a 2 minus 3, 1/2, and 5. So this is our answer. Okay, the next example, find a third-degree polynomial function with zeros at x equals 2, x equals 7i, and x equals negative 7i. Well, this is actually pretty simple. So you just say 0 equals x minus 2 times x minus 7i times x plus 7i. And then you multiply these together. Well, this becomes x squared plus 49 if you FOIL it. And then we bring down the x minus 2. That again is equal to 0. And now we FOIL it one more time. 0 equals, so let's do the first, x times x squared, x cubed. Inside, well, FOIL stands for first, outside, inside, and last, so we'll do outside. X times 49 is a 49x. Inside, minus 2 times x squared is a minus 2x squared. And last, minus 2 times 49 is minus 98. And now we just want to put it in descending order. So we can say f of x is equal to x cubed minus 2x squared plus 49x minus 98. And that is your answer. Okay, the next example, finding 0